The question today is, how can we find an explicit formula for this kind of sequence? For example, we have a0 is equal to 3, and we know an is equal to 2 times an minus 1, and this just means the previous term. After that, we add the 5. The question is, how can we find an explicit formula for this? By the way, an explicit formula is a formula based on n only. This formula is based on the previous term, which is not ideal sometimes because if you want to figure out a100, you will have to know what a99 is. And likewise, to know a99, you will have to know a98, etc. But if you have an explicit formula, you can just plug in 100 into n and work it out. So how can we do it? Here, let me show you guys the longer way first, and then I'll show you guys the quick way later on. Here we go. If you start with an, which is by definition 2 times an minus 1 plus 5, and this is the example of the first order linear recurrence equation because they are all to the first power, and also it's just one difference, right? N and the previous term. You can do the following. Give it a try. What we will do is look at this term and apply this formula. So we have this 2, plugging n minus 1 to here and here, so we get 2, and then we will have an minus 2 and plus 5, and then plus this 5. Yeah, and I will do it again. I will keep this, but for the an minus 2, we're plugging this right here into here and here, so we get 2an minus 3 and then plus 5. This thing is for that, so I'll put parentheses right here and then plus 5 and then plus 5. Now, you'll just keep on going until we have 2 times 2 times 2 and so on, so on, so on. And at the end here, inside, you need to have 2 times a0 and then plus 5 and then plus 5 and so on, so on, so on. And then at the end, you have the plus 5 at the very end. So it's like this. Okay, how exactly can we get this to work? We'll look for a pattern. So firstly, if you look at an minus 3, right here we have 3 2's. So this is how I look at it. Right here, I will have 2 to the third power, and then we will have an minus 3. So you can see that the 3 and the minus 3 match. So later on, right here, we must have 2 to the power of n, and then this right here is a0. Together, they have to add up to n, just like this. 3 and n minus 3, they add up to n. Okay, now, for the 5s, they are trickier. Okay, let's see. Take a look at the first one, this is just 5, but for this one, okay, this is 5, but you have to multiply the 2, right? So if you keep track of the 5, right here, you will get, let me just 2 to the 2 times an minus 2. But anyway, for the rest, we will have to do 2 times 5, and then plus 5. But for this one, have a look on the inside here. How many 2's do we have to multiply? Not this one. 2 of them will get distributed to this 5. So we will have 2 2's and then times 5. How about for this 5? It's just 1 2 from here. And how about for this 5? None, it's just 5. So if you look at this part, we can factor out the 5, and then we can get 2 to the second plus 2 to the first and plus just 1. So if you look at this right here, same thing, we can factor out the 5, but notice this 2 is 1 power less than what you have here. So right here it's 2 to the n minus 1, and it's a geometric sum. So plus 2 to the n minus 2, and so on, so on, so on, up to 1, like this. Well, this right here is not in the closed form yet, but this is just the geometric sum. It's a finite version. We can calculate this with the formula. To do so, if you look at this as the first term, it's just 1 times the common ratio is 2 because you multiply by 2, right? And if you look at the highest power is n minus 1, you add 1 to it. So it's 2 to the n, and then minus 1, over the common ratio minus 1. So it's like this. So have a look. You can simplify all this and you get 2 to the n times a0, which is by definition 3. So we have 3 times 2 to the n. And then for this, the top is 2 to the n minus 1, and the bottom is 1, doesn't matter. I will distribute the 5, so it's plus 5 times 2 to the n, and then 5 times negative 1. And now we can combine this and that. So that is 8 times 2 to the n minus 5. And in fact, we're pretty much done. And in fact, you can see the pattern. It's always going to be an times 2 to the n plus 5. So depend minus 5. And then notice the 8 is the same as 2 to the third power. So all in all, we can write this as 2 to the n plus 3 and then minus 5. Whew. Yeah, so this will be an explicit formula for that. So this is how it goes. If you look at just this part right here, 2 times an minus 1 is equal to an. This is just a geometric series. So here's the idea. Suppose we didn't have the plus 5. An is equal to 2 times the previous. This is just a geometric sequence, right? Just keep multiplying by 2. It's just that plus 5 is bothering us. So this is how we can fix it. This is called the fixed point approach. We are going to think about what number to add, or depends how you want to look at it, on both sides so that we can make this work. Here, if it's a 2, then just add this number both sides. Have a look. An, I'm going to add 5 to both sides. This is plus 5, and I will plus 5. Why? Because this will be an plus 5, and that's 2 an minus 1 plus 10, and I can factor out the 2. And you see an plus 5 is equal to 2 times an minus 1 plus 5. Now have a look. If you treat this and that as our new inputs now, we can call this bn, and this right here will just be bn minus 1. So we see bn is equal to 2 times bn minus 1. That's the idea. And if you look at this as bn, bn is just a geometric sequence. So here's the recap. If it's a 2, then just add the same number on both sides. You can think about if it's a 3, what number do you have to add, right? Anyways, right here we have a general form for bn. When you have a geometric sequence, it's always going to be the first term, which is b0 times the common ratio. Here we have the 2 raised to the power of n. Here we use n because we started at 0. If this is starting at 1, then right here will be n minus 1. But anyways, this is pretty much it. And have a look. bn is what? bn is just equal to that. So we can say an plus 5 is equal to what's b0? b0 is not 3. b0, I'll just do this right here real quick. b0 is equal to, well, you put 0 in here, so it's a0 plus 5, which is 3 plus 5, which is 8. So right here, this is 8, and then times 2 to the n. Subtract 5 from both sides. An equals this, just like what we have went over. What? This is just like what we did earlier. This is 2 to the n plus 3 and then minus 5. Ladies and gentlemen, we are done.